Absolute uncertainty. Absolute uncertainty is a very important concept when we are doing measurements that includes increments. That is why you have to figure out up to how many decimal digits you have to report your reading. When we are making measurements with linear scales, there are two things that you have to pay attention with. The first one is to calculate the size of the increment. When we are looking for the size of the increments, they fall into three families. One is the family of twos. The family of twos include any increment that has 2 in it. For example, 0.02, 0.2, 2, 20, and 200. Therefore, anything that has 2 in it, or any increment that has 2 in it, belongs to the family of twos. Next one is family of 5, which means any increment that has 5 in it. For example, 0.05, 0.5, 5, 50, 500, 5,000, 5 million, etc. And the third one is the family of tens, which means any increment that has 1 in it. It's 1 and it's not 10, okay? It has to have 1 in it. For example, 0.01, 0.1, 1, 10, 100, etc. So any increment that has 1 in it belongs to the family of tens. Then one more time, we have the family of twos, fives, and tens. Family of twos are those increments with 2's in it, like these examples. Family of 5 are those increments with 5 in it, like these examples. And families of 10 are those increments with 1 in it, like the examples that are mentioned here. Now, the second thing that you have to pay attention to is how to calculate the absolute uncertainty. This is the equation that we use to absolute uncertainty, okay? In order to calculate the absolute uncertainty, we divide the increments by family. Then we have 3 families, as I discussed in the previous slides. 2's, 5's, and 10's. These are the 3 families. And using the absolute uncertainty, we will find the location of the last sig fig in the measurements. That's how important. Then you need to memorize this equation. This needs to be memorized. Okay? And you also need to know and memorize, the families. The families also need to be memorized. Okay? All right. Now, let's do a couple of examples so that you will know what I mean by absolute uncertainty, calculations, increments, family, and all of that. Okay? Let's do examples. Let's do this example. Assume this is a thermometer. And starts from, let's say, 0 degrees Celsius. Then we go to 10. And then it goes to 20. And it goes to 30. Okay? And then the increments goes 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. 1, 2, 3, 4, and etc. Okay. We're gonna do a reading. And let's say my reading, I want to ask you to read the temperature. Let me do it one more time. Okay. At this point, I want to know at this point, what is the temperature? Okay? you're going to do the reading at this temperature. Okay. Then the first thing that you want to do the reading before doing anything, you see this is a thermometer. You see it has increments on it. Then the first thing that you want to do is to figure out what the increment is on it. Okay? Then if you look here, from 0 to 10 degrees Celsius, we go up by 2. Okay? The increment is 2. Because it's 0, the next one is 2, 4, 6, 8, and 10. Okay? That means, as you can see here, we go up by increments of 2. Okay? That means from 0 to 10, we go from 2, 4, 6, 8, 10. That's why the increment is 10. Oh, sorry, it's 2. Okay? That's the increments on it. Now, what family belongs to? Remember, anything with 2 in it belongs to the family of 2's. The next thing that you want to do is to find the absolute uncertainty, which is increment divided by family. This will be 1. Then the absolute uncertainty means 1. When it's 1, it means you have to report your reading with to a whole number. Okay, it has to be a whole number. Okay, then if the absolute uncertainty is 1, the absolute uncertainty could be either 1, 0.1, 0.01, etc. That's how it's gonna be. Okay, but this one it's 1, which means your number has to be reported as a whole number with no decimals on it at all. Then if you look at this exactly location, then it's gonna be 10, 12, 14, 16, and 18. It's somewhere between 16 and 18 degrees Celsius. And you could guess it, okay? That part, you need to guess it. Then it's not 16 degrees Celsius, it's not 18 degrees Celsius. You could call it 17 or 18. It's not sitting on 18. That's why I'm going to call it 17 degrees Celsius. That's what the temperature is going to be. Okay? And that's the temperature that we're going to read off of this thermometer. Okay? Then what I did first, I found the increments. Then from the increments, I look for the family. And once I have the increments and the family, I plug it into the equation that I gave you on the previous slide, which you have to know, and I found the absolute uncertainty. Once I know the absolute uncertainty, I have to figure out up to how many decimal digits I have to do my reading. Then based on this, the reading has to be reported as a whole number. Then once you know the reading has to be reported as a whole number, you go back to your thermometer and do the reading. Then the reading cannot be 16 or 18. It has to be somewhere in between. And it cannot be 16.5. 16.5 is wrong. Because why? Because of that decimal digit. It should be a whole number. Then it's going to be 17. Okay? Let's do one more. Let's do another thermometer. And it goes from, again, 0, 10, 0, 10, 20, and etc. Okay? And it goes up by, this is the increments. Okay? That's the increment. We're going to do the reading at this point. Let's do it at this point. You want to do it at this point. You want to know what is the temperature at this point. Okay? Again, the first thing that you want to do is to find the increments. Alright, look at the thermometer from 0 to 5. Okay, sorry, from 0 to 10. Okay, or from 10 to 20. We're going up by 5. Then it's going to be 0, 5, 10, 15, 20, 25, and etc. Right? Then it goes up by 5. That's the increment. Now, What family does it belong to? The increment has 5 in it. Anything with 5 in it belongs to the family of 5s. Okay. Then now that we know the increments, we know the family, we could calculate the absolute uncertainty, which is going to be increment divided by family, and here we get 1. Okay. Again, just like the previous example, you have to report your reading as a whole number, which means it has no decimal, with no decimal on it. Okay. So now look at the temperature. The temperature is somewhere between 15 and 20. Again, not on 15, it's not 20. Somewhere in between. We could say I would say it's 18. Okay. 18, 19. You could say something like that. I will say 18. Okay. Even 19 or 19 degrees Celsius. Then either one is correct. And as you could see here, I reported as a whole number. These readings are as a whole number. Okay. It should not have any decimal on it based on the absolute uncertainty that we figured out. All right. Let's do one more example. All right. Then if this is our 0 degrees Celsius, this would be 10. This would be 20. Okay. I'm gonna report a reading at this point. Okay. We want to know what is the temperature at this point exactly. Again, what you want to do is to find the increments. That's the first thing. Now look, from 0 to 10 or 10 to 20, okay? Then we go up by 1 degree Celsius because it's going to be 0 degree, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, then we go up by 1 degree Celsius. That will be the increment. Now, what family does it belong to? Then anything with 1 in it belongs to the family of 10s. We do not have a family of 1s. We have 2, 5, and 10. Then any increments or any measurements with 1 in it belong to the family of 10s. Then once you know the increments, you know the absolute uncertainty. We know the family, we calculate the absolute uncertainty, which is going to be increments divided by family, and that will be 0.1 degrees Celsius. Now here, the absolute uncertainty is 0.1. What does that mean? That means report your reading up to 1 decimal unit. Okay. When you're reading, now it's not a whole number. It has to be reported up to 1 decimal unit. Okay. To 1 decimal unit. I'll fix that one so that it would not be confusing. Now let's look. We want to find out the temperature at that point. Then it's 0, 1 degree, 2, 3, 4, 5. Then as you could see here, that temperature is sitting exactly at 5, right? Then if you say it's 5 degrees Celsius, it will be wrong. Why would it be wrong? Because you're not following the absolute uncertainty that you calculated it. Your reading has to be reported up to 1 decimal unit, which means the temperature is 5.0 degrees Celsius. Okay, and that's how it works. Then the absolute uncertainty, let's do a little side note here. Okay, it could be 1, 0.1, 0.01, and etc. Okay, then if it's 0.1, that means reading reported as a whole number. If it's 0.1, it means reading reported in 1 decimal unit. If it's 0.01, the reading has to be reported in 2 decimal unit, and etc. Then you will not get absolute uncertainty as like 500 or 20 or 2 or anything like this. It can be either 1.1, 0.01, and etc. If you got something like in that regards, like 2, 20, like 4, like 12, these numbers, then you made a mistake somewhere. Okay, then this is the end of teaching absolute uncertainty. And as I said, whenever you're doing any kind of measurements, if you're in the lab or if you are doing something, some sort of calculation that you are told that instrumentation has increments on it, you have to do the absolute uncertainty. Okay, it's really important that you follow the rule. Okay, all right, that's it. Thank you for listening. Bye for now.